All right, good afternoon. It is the Equation Slayer with two special guests, Kay Dizzle and Jay Steady, and we're going to go over a triangle congruence proof. All right, so if I'm given that AE bisects angle BAC, and we know AB is congruent to AC, prove angle B and C are congruent. Well, of course, we're going to start with the given. We know AE bisects angle BAC, which is given. From here, because it's a bisector, I know these two angles 1 and 2 are going to be congruent because we're bisecting that angle, and that's of course the definition of a bisector. Now, of course, we didn't use the whole given yet. You might be waiting for AB to be congruent to AC, and here's where that happens, and we'll call that the given. And then from there, you can see that we actually have an overlapping line. They both have side AD, so we can actually say it's congruent to itself by the reflexive property. And then we have, of course, side-side angle. We have this side congruent to this side, congruent to these two angles, and so the triangles are congruent. And then if I have two congruent triangles, then these corresponding angles, angle C and B, must be congruent by CP, CT, C. All right. Kay Dizzle, show them how it's done.
All right, Kay Dizzle here now with my proof, and this obviously will be correct because it is in fact my proof. So I started the same way. I know that ray AE bisects angle BAC, and that was a given. Then I also know that segment BD is congruent to segment CD, and I know that because that's a definition of a bisector. Here's my ray, and I'm bisecting here with BD congruent to CD. After that, back to another given, I see that segment AB is congruent to segment AC, and that also, again, is a given. Again, I see two triangles that share the same side, so I can call that common side. AE is congruent to itself using the reflective property of congruence. Now I have triangle ABD congruent to triangle ACD by side-side-side congruence. Last but not least, I can then say that angle B is congruent to angle C because of CPCTC. Jay Steady, on to you.
Okay, we got Jay Steady in the house. You ready for this? Obviously, my proof is the correct one, so listen up. So we're going to start off with our given again. If I can find the mouse. We know that ray AE bisects angle BAC, that's a given. And then, based on our definition of a bisector, we can also say that angle BAD is congruent to angle CAD, because that ray bisects that big angle. From there, we can move on to one of our other given terms. We know that side AB and side AC are congruent on these two triangles. And then we're going to go on and work with this line, this segment, in the middle that both of our triangles share at segment AD. And by the reflexive property of congruence, we can say it is congruent to itself. Now we have enough information to say that triangle ABD is congruent to triangle ACD by side angle side. And once our triangles are congruent, we can say that the angles we care about, angle B and angle C, are congruent by CPCTC.
All right, let's see if you guys can figure out which one was correct. Good luck. Equation Slayer signing out. And
Kay Dizzle signing out.
Jay Steady signing out.
please subscribe to my page.